Yellowstone is one of the world's most powerful supervolcanoes. A single eruption could be enough to devastate a national park for miles around and spread the damage to other areas if the explosion is powerful enough. Scientists are concerned about the recent activity and the discovery of free-flowing magma beneath the surface. While often the greatest fear for researchers, other supervolcanoes in California are also a cause for concern due to the intensity of earthquakes and the movement of magma beneath the surface. Not many supervolcanoes exhibit this kind of activity. This type of natural killer volcano is characterized by its ability to eject material as far as 1,000 kilometers into the atmosphere. The last eruption of this volcano occurred thousands of years ago. Some of the world's most famous volcanoes include Lake Toba, Lake Taupo, the Ira caldera, Yellowstone, and the Long Valley caldera in California. In the United States, only the Long Valley caldera and Yellowstone exist. Other volcanoes have incredible destructive power, such as the one that destroyed Pompeii in the past, and the famous city of Naples in Italy is now built right next to it, or several volcanoes in Hawaii, which frequently spew lava. In California, a lot has changed since the new seismometer readings came in. A new study by researchers at the California Institute of Technology, Caltech, shows that the Long Valley caldera in eastern California is slowly shrinking as its magma chamber cools. This supervolcano last erupted about 100,000 years ago. The previous eruption was so powerful that it covered what is now Los Angeles with nearly a kilometer of ash. Today, the caldera appears calm on the surface, but in the late 1970 seconds, it began producing a series of earthquakes and periods of turbulence that caused the ground to rise and fall. Scientists now believe that this activity does not indicate another catastrophic eruption is imminent. Instead, this movement is likely part of the volcano's cooling process. According to geophysicist Zhongwen Zhan, the release of gas and fluid during cooling can still cause occasional earthquakes and small eruptions, citing a cluster of magnitude 6 earthquakes that rocked the region in May 1980. To study the supervolcano's caldera more closely, researchers used a 100 kilometer long fiber optic cable that acted as a giant seismic network. Over a year and a half, the system detected more than 2,000 seismic events, many of which were too faint for humans to detect. The data was then fed into a machine learning program, which produced one of the most detailed maps of the volcano beneath Long Valley. Scientists recently gained a better understanding of what's happening at Yellowstone using similar technology. Lead author Ettore Biondi explained that this is the first time such a vast network of acoustic sensors has been able to reveal the structure of the Earth's interior with such precision. The images show the caldera in stunning detail, not only at shallow depths, but also up to 30 kilometers underground. Researchers have discovered that this California supervolcano has two main systems beneath it. Deep beneath it, about 12 kilometers below the surface, lies a massive magma chamber. Above it lies a shallower layer filled with hot water and steam. As the deeper magma chamber cools, gases and fluids likely rise to the surface, triggering earthquakes. Scientists believe the supervolcano is slowly subsiding, with its beating heart deep underground beginning to subside. To track this process, they placed seismic sensors along a 200 kilometer long fiber optic cable, about 20 kilometers deep.